Algebra 1 students, this is the third and final video for section 8.3. So in your note packet, there's a couple of examples at the back with just a different strategy for graphing. So this is page 5 in your note packet. Where's page number? There it is, and example 5. So you'll notice it says use the vertex and the zeros to graph. So those are both useful points when we're graphing, and this saves you a little work, gives you a pretty good graph without having to do a table of values. So remember, for finding the vertex, our first step is identifying A, B, and C. So A is 1, B is -2, C is -8. I'm going to zoom in a little bit here for you. All right, now I want to use the formula x equals -b over 2a. So negative RB is -2. In the denominator, you have 2 times RA, which is 1. And then we just simplify that. So again, make sure when you're substituting in your b here, you wrap it up in parentheses. This is a perfect example of why, because I have a negative times a negative. That's like -1 times -2. That gets me +2. In the denominator, 2 times 1 is 2. 2 divided by 2 is 1. So that's half of my vertex, remember. And it's also my axis of symmetry. I'll just write that in, even though this problem does not ask for the axis of symmetry. Okay, now I need to find the y that goes with x equals 1. So this is the equation I'm going to use. Y equals, I'm going to substitute 1 in for x into my original function that I was given. So y is going to equal, instead of x squared, it's going to be 1 squared, because I am substituting in 1 for x, minus 2, just copy that. When you get to the x, substitute in 1, and then minus 8. If you have your parentheses here, you can put that whole thing in the calculator. This one's just 1, so I'm thinking, I kind of have a glare here. I'm trying to fix that up for you. I'm thinking we can just do this one. So 1 squared is just 1. 1 minus 2 is -1. Minus 8 would be -9. Oh, I think I did that wrong. Let me backtrack here. 1 minus 2 would be, oh no, that's right, would be -1. Okay, -9. I think I'm good. All right, so my vertex is at 1, -9. So I'm going to graph that right now. Over 1, down, -9. There's my vertex. My axis of symmetry, remember, goes right through my vertex. And this A is positive, so this is going to be upward facing. So I know this is the bottom. I know it's going to be upward facing. If I can find my zeros or my solutions or my x-intercepts, that will give me 2 more points, which will give me enough to do what I call a pretty good sketch. So remember, to solve, finding zeros is the same as finding solutions. So remember, when we're finding solutions, we're finding x-intercepts, or we're finding where y is 0. So I'm going to solve this equation. 0 equals x squared minus 2x minus 8. These are what we did in chapter 7. We solved by graphing. This one is, we solved by factoring. So we're going to factor this, and then we're going to use that zero product property, ZPP, and we're going to solve and find our 2 x-intercepts. So A is 1, B is -2, C is -8. We already know that. So our method for factoring was x box. At the top of the x, we did A times C, which would be -8. At the bottom of the x, we did B, which would be -2. So two numbers that multiply to give me -8. I'm going to have one positive and one negative. I'm thinking those are 4 and 2. And then when I add these, I need to get -2. If this is negative, make the bigger factor negative. So -4 times 2 is -8. -4 plus 2 is -2. Remember the shortcut. If a is 1, I don't have to do the box. So my factors are x minus 4 times x plus 2 equals 0. So remember, we're equal to 0. This is a solve problem. Zero product property says if two things multiplied together equal 0, two terms multiplied together equal 0, then one of them or both of them must equal 0. We say both of them, and we solve both those equations. I'm going to add 4 to both sides here. X equals 4 is one of my solutions. -2 minus 2. X equals -2 is my other solution. So the zeros are x equals 4 and x equals -2. Okay. Remember, there's 4 names for this: zeros, solutions, x-intercepts, and roots. They're all the same thing. They're all these points on the x-axis where my parabola intersects or crosses the x-axis. So I'm going to put a point at 4 and a point at -2. So now I know this is what my parabola is going to do. And then also y-intercept is a 4th point. Remember, the y-intercept is your c value. So my c value is -8. So I know if I go to -8 on the y-axis, my parabola is also going to go through that point. If you notice that this -8 is 1 to the left of the axis of symmetry, then you're going to have another point 1 to the right of the axis of symmetry, because this axis of symmetry splits it right down the middle, and all these points are symmetrical. Notice this is 1, 2, 3 spaces to the right of the axis of symmetry, and this other 0 is 1, 2, 3 to the left. So now I can do a pretty good graph here. And I didn't have to do a table of values. Let's look at one more of these. Again, it gives me a pretty good clue. It says use the vertex and zeros to graph. So let's first identify A, B, and C. I'm going to put it above here because I don't have a lot of room below. A is 3. B is 6. And if you notice, I don't have a C. If you don't have a C, it's 0. I'm trying to figure out this glare. All right, so vertex x equals -b over 2a. X equals negative, b is 6, over 2 times a is 3. -6 over 2 times 3 is 6. -6 divided by 6 is -1. That's half of my vertex, remember? Let's find the other half. Y equals 3x squared plus 6x, but I want to find out the y value when x is -1. Remember, this means x is -1. So I'm going to substitute -1 in wherever I see an x. So I'm going to have 3 parentheses -1 squared plus 6 parentheses -1. So make sure you're wrapping your value that you're substituting in, make sure you're wrapping it up in parentheses, especially when you have a negative like this. If you do that, you can just put this whole thing in your calculator. Don't forget the squared on that first -1, plus 6 parentheses -1. And I get -3. So this means when x is -1, y is -3. So there's my vertex. So let's graph it over -1, down 1, 2, 3. A is positive, so I know I'm going to be opening up. Now let's find our zeros. And remember, we're going to do that by factoring. The reason they're called zeros is we're finding x when y is 0. So let's replace this y with a 0, copy everything else, and then factor this. Now I can do Xbox on this, but I'm noticing right away that I have a common factor here. I have a 3 that's a common factor because 3 goes into 3 evenly and 3 goes into 6. And also both of these terms have an x. So I'm thinking I can just factor out my greatest common factor here, and then I will be done factoring. So remember, factoring is just the same as dividing. So if I picture dividing this term by 3x, 3 divided by 3 is 1. X squared divided by x is x. If I divide this term by 3x, put the plus in the middle there, 6 divided by 3 is 2. X divided by x is 1. So I get that. Now let's check it. Do distributive property on this. 3 times 1 is 3. X times x is x squared. Good. 3x times 2 is 6x. So remember, you can check and see if you factored it correctly. Just want to remind you, when you're factoring by GCF is also when you can do your trees. So this is 3 times 1 and 2 x's. This is 2 times 3 and 1x. 3 is common. 3 is common, x is common, x is common. So 3x is my GCF. And what are my leftovers? X and 2. All right, now if you look at this, I have a term multiplied by a term equal to 0. So 0 product property says either 3x equals 0 or x plus 2 equals 0. Well, let me put that 0 on the other side to be consistent here. So solve both of these equations. To get x alone here, I'm going to divide both sides by 3, and I'm going to get x equals 0. 0 divided by 3 is 0. Here I'm going to minus 2 from both sides, so I get x equals negative 2. So the zeros are x equals 0 and x equals negative 2. My y-intercept, c is 0, so my y-intercept was 0. So let's graph these first. So put a point at 0 and a point at negative 2. Remember, these are x-intercepts or zeros, so they go right on the x-axis. My y-intercept is also 0, so that's the same point. So this time I have 3 points, but I can do a pretty good graph with just 3 points. Okay, so that is it. There is one for you to try on the next page, so you should do that one before class.